All right. In chapter 3, the very beginning of chapter 3 is a reminder on component vectors. Where if you are given a vector, and a vector on an angle specifically, we can break them down into components by taking the vector itself and multiplying by the sine or the cosine of whatever angle it happens to be located comparatively to. So since y is opposite, which one should that be? Sine or cosine?
Sine.
Sine. Okay. When it comes to projectile motion, we also refer to it as parabolic motion. The initial angle can be broken into components of v naught x and v naught y using these formulas. The final component can be broken into vy and vx components as well. What were some of the assumptions of two-dimensional motion? Anybody remember?
Vx equals v naught.
Right. So constant x motion, but only in the horizontal direction. This also meant that a in the x direction was 0, always. Okay, what other assumptions could we make?
Is this one y equals negative g?
Yeah, so ay when a equals negative g. So in other words, we can use the x component formulas, and we can use the y component formulas, and we can make these assumptions, which led us to what those formulas were. The last one is vy is 0 at the top of the path. This is the chapter where we use protractors to measure angles, to draw vectors, where we did vector addition. So if we added two vectors together, the resultant was the sum of the two vectors. I'm just gonna... Right? So if we knew information about A and B, we could figure out R using a couple of different formulas. Remember that the resultant formulas those guys. The two-dimensional kinematics formulas. Were also something that we talked a little bit about. There was only one x direction formula because of this, because A is always 0 for the x direction, it meant that there was only that formula to worry about in the x direction. In the y direction, though, you had a couple of different ones. So these assumptions led to these formulas, both x and y. And yes, I will do a problem here in a little bit. But before we do that, I just want to get through the last ones. There were steps to solving this particular type of problem. Always draw a picture. It's always up there somewhere. Identify your knowns and unknowns. Identify the equations. Ask yourself if it makes sense. Sounds about right. Projectile motion. Okay. So that was section 4 of chapter 3. Section 5 talked about addition of velocities, so just the same as like the a plus b makes r, and being able to figure out that if you are given 2 of these things, could you figure out the other? So section 5 said a plus something equals r and gave you a and r and asked you to calculate the b. Whereas before that it had always been given a and b, tell me what the resultant is. Okay, so this is like what was the current of the river, what was the speed of the wind against the airplane, things like that. All right, so next thing I'm going to do is I'm going to work on a couple of just the problems that we went over in chapter 3. Tomorrow I'm reserving for chapter 4, just to kind of go back over some of Newton's laws, the free body diagrams, the F-net equations that we worked on all last week and during remote learning. So if you have questions over chapter 4, please make sure you bring them with you to class tomorrow. All right, let's look. That is not what I want. Do I need to go over a problem involving adding 2 vectors and getting the resultant, or do we feel okay about that? I can work it into a projectile motion problem where we do like the ending path. Those problems where you were told to find what the direction and all of that was of the very last thing is something that we can work it in.
Can you do this?
This one?
Yeah, I mean.
Yeah, that's one of those addition velocities.
Oh, okay.
Yeah, we can do that.
Cool, yeah. I'm just gonna leave that there.
Do you just want me to write it? I'll write it down. Give me a second. Can I erase these formulas? Hopefully you have them in front of you or you have access to them. They're on the Canvas for this week. again, the day you come for your final exam, you will be given a copy of the formulas, so you do not need to bring one. You'll also be given an answer sheet, looks something like this, very blank. You're going to put your number and your work for any of the problems that require that you do work, right? So if you have to do something along the lines of solving a problem, show your work. Anything you show your work on is worth partial credit. Right? Now, obviously there are some multiple choice questions. It would make no sense for you to show your work on. Don't do that. There's only like 12 or 15 spots, and there's 30 questions on your final, so it's not for every problem, just so you're aware. All right, I'm going to do this problem that Jessica handed me. It's on the addition of velocities. So it says a river flows from southwest to northeast with a velocity of 7.1 meters per second. A boat captain wants to cross this river to reach a point on the opposite shore. Boat moves at 13 meters per second. What direction should the boat move? What direction should it head towards if 19.74 meters per second? Okay. From southwest to northeast. So I'm going to draw myself a river. That's where I'm going to start. Southwest is third quadrant, right? Northeast would be first quadrant. I think the implied angle here is 45 degrees because it's moving that angle, right? I think that's the implied angle. And it says V equals 7.1 meters per second. Okay. The other one says resultant is 19.74 meters per second to get to the opposite shore, so the resultant. This plus whatever the boat is moving. My guess is when a boat sets out, and disagree if you think, if the boat sets out, it's probably just trying to get across in the most efficient manner it can, correct? So wouldn't you assume it's going straight? Yeah, okay. So, this is the boat. We're told 13 meters per second. Okay, the last thing we're told is the resultant is 19.74 meters per second. So this plus this is going to be 19.74. Since this is a big number, I'm going to assume the resultant has to be the hypotenuse of whatever triangle I'm drawing here. Which should make sense once we put it all together. Okay. So can I redraw this as an addition? Instead of drawing them from the same point, I'm going to draw them as if they are adding together. Right? B river, B boat. This one is 7.1. This one is 13. R is 19.74 meters per second. Okay. Now what? What can we do with the given information? And remember that this is a 45-degree angle for the resultant. I'm sorry, for the river. I want to know this. I want to know that theta r. That is the identified direction in which the boat will end up traveling. Okay? So, if I want to know this value, I need to know x and y components of everything involved, right? Okay, so how do I get x and y components of VR?
7.1 cosine 2045.
Yeah, so we're going to do VXR and VYR. And since cosine and sine of 45 degrees are going to be identical, because 45 degrees is that like perfect angle, right? It's going to be 7.1 cosine of 45 degrees and 7.1 sine of 45 degrees. If you mess them up, it doesn't matter because it's the same. So what are my values going to be then? 5.02? Okay. All right, what else? The V of the boat. Okay, we said the boat was heading in a straightly horizontal direction, right? So what is the Y of V boat? 0, right? So VBX and VBY. VBY is going to be 0, we just said. VBX is going to be all of the velocity, so 13. So now let's do Rx and Ry. So Rx should be technically, R should come out to be 9.74 meters per second. That's what we were told. Boy, I hope it kind of does. We were also told that that. I feel like those numbers aren't going to come up right. Hmm?
Sometimes if we do like a
Squared.
yeah, sometimes 18.7. I mean, if you do square.
Yeah, I got 18.71. So it says that R should be 19.74.
We should email OpenStax and tell them that they're wrong.
Yeah, I mean, you should know, I've spotted errors in their problems before. They just launched OpenStax Tutors this year, so be patient. But that being said, was this one of the questions from chapter 3?
Yeah.
Okay.
So we outsmarted OpenStax.
But this is how I would approach this problem, right? And I would also word it differently so that you understood the boat was going straight horizontally and the angle on the river's current was 45 degrees. So I would give you more information than they gave you too. That's kind of something else to recognize.
Okay.
So then what would the angle come out to be if we did this? Let's do it our way. Because I said so. Anybody know?
15.56.
So then, does that make sense? If you think about the adding of these two together, does it make sense that the angle of the overall movement ends up being 15 degrees? It's less than 45, right? It's a pretty shallow angle. It makes sense that this thing is trying to move at 0 degrees, but the current pushes it up, doesn't it? Hopefully you see that it makes more sense this way. Boy, Ben! Yes?
Maybe I missed something.
I think at the end of it, I would give you more information. That's the lesson to take from that problem. Yes?
Maybe I missed something. Where'd you get 45 degrees from?
So it says it moves from southwest to northeast. That was an assumption I had to make.
Oh.
Okay? Yeah.
Okay. So how would you that?
How would I alter the problem? Is that what you're asking?
No, like they ask what direction.
They're asking you the direction on R. Because if they're I guess the question that I would pose to you is what direction does the boat appear to move? Is the question here. Because we're assuming the boat is trying to move 0 degrees, right? Straight. Because it says it's trying to get to a point on the other side. It doesn't say if the point is supposed to be directly across or if the point is like a specific location. It just says they're trying to get to the other side. And the most logical approach to trying to get to the other side of the river would be straight, right? Not going left, not going right, not going against the current or with it, kind of thing.
It'll probably be more like northeast.
Yeah, so since it's moving from here to here, the 15 degrees being in the first quadrant makes sense. Does that make sense? Okay.
So you said that this was like an A plus B equals all, like it's more like the 0.5 one?
Yeah, I thought it was more of a 0.5, but it ended up being more of the
Result, okay.
A plus B equals the resultant.
Oh, okay.
The only difference and the reason I thought that was because R was given.
Right, so then,
Does that make sense?
yes.
Okay.
So then, like Lizzie said,
Just
what direction would the boat move? Like the choices that they gave, like they're not really making sense. But maybe that's because we got 18.2.
If the questions that they gave you had something shallower than 45 degrees and positive, then I would choose that one. If there was more than one of those, I'd choose probably the shallowest. I don't remember what were the options they gave you.
It heads in the direction 22.6 degrees east of south, or it heads in that same direction except southeast,
Hold on. East of south is down. So that's, no,
and
not
then
east of south.
southeast 22 degrees,
That's in the same order. Keep going.
and then 45 degrees east of south,
Okay.
and then 45 degrees southeast.
So they're all in the fourth quadrant.
Yes.
Doesn't make sense. So how does that, so I guess then my next question to you would be, does that make sense to you? Based on what we were given about this, it moves from south to north, the current, right?
Yes.
Why would the boat move against the current?
Because the captain.
The captain is Gilligan.
Yeah.
Yeah, okay. Yeah, so I would say it's just not a very well worded problem,
Yeah.
is my opinion. I would not give you something worded like that. Okay? Deal? I won't give you a problem worded that weirdly. Okay, let's do projectile motion next. So let's talk something shot out of a cannon. Whoa.
Thank you for doing that problem.
Yeah, that one is odd duck. I'm sorry.
I have it.
Do you really?
I do.
Is it a projectile motion problem?
It is a. Oh wait, I think it actually is.
Is somebody being shot out of a cannon?
A water balloon.
Cool. How far away means X, right?
Yes.
Okay, guys, here we go. Water balloon being shot out of a cannon at 30 meters per second, 50 degrees above the horizontal. So when we say above horizontal, what does that mean? The terminology above the horizontal means above the ground, right? Okay. And we always draw it so that that means that this way is positive, right? So we're told this is 50 degrees and that V naught is 30 meters per second. Okay. Question is, how far? Question I want to remind you of. What is the optimal angle? Thank you. Why do we say optimal angle? What will happen if we shoot it at 45 degrees?
It will go farthest length.
It will go the farthest range, right? So we're talking about the X direction if we shoot it at that way. Is that also the optimal angle for height? No. What's the optimal angle for height? 90 degrees, right? So think about this. This is for range. Okay. You remember the range formula?
It's a fraction.
Could we use the range formula? Why?
Because we have velocity and the
What are the requirements for the range formula?
velocity.
Does anybody remember? In order to use the range formula, your object must start and end on the ground. So if this were a platform that was raised in the air, we could not do this. Because the range formula makes the assumption that y initial and y final are the same. Okay? So the range formula, it's like 2 theta. Oh, yeah, okay. V naught squared times the sine of 2 theta all over G. Real quick, for argument's sake, let's set up an XY table and see what we get. And then let's discuss why the range formula would be the best one to use in this particular case. So remember to put all of your variables. Hopefully you remember your variables. Uh-huh.
Actually, do I?
At this point, you've written them so many times.
Yeah, I think it's like hard not to.
Fill in what you know. What else do we know? What do we know about x naught? 0. What do we know about y naught? 0. It's going up and coming back down, right? So what is y?
0.
Also 0. What other pieces of information can we garner from what we were given? We can find our components, right? We can get v naught x and v naught y. And v naught x also equals final x, so let's do that. So every time I do a problem, I have to remind myself of the triangles, so don't feel bad if you're still doing sine, cosine, tangent in your head. I've been doing it for like 30 years. Right? So don't forget your trig. We're going to save this for later. Okay. What do we get for v naught x? Calculators.
What are we supposed to plug in for V?
Oh, 30.
Oh, okay. Don't
Sorry.
For VOX, I got 28.94.
Don't forget degree mode.
Yeah, that's fine.
I got 28. For cosine, I got 19.28. For sine, I got 22.98.
Okay, hold on. 22.98
I also got
and 19 point.
2.8. Okay, I was in the wrong place.
All right. So plug them in.
I'm really sorry about that.
We're fine. Okay. So let's notice that we have a few holes in our logic here. What can we do to get to x? Because remember that this is the formula that we have to use to get to x. So can we just plug numbers in and go? No, what are we missing? We need time. So let's look at our y formulas. Let's look at our y formulas and realize that we're going to have to use this one. But here's the good news. It's not going to be a quadratic. So we're going to solve this for time. And then we're going to solve this for x. And then we'll use the shortcut formula just to prove to ourselves that our answer is correct. Okay? But for now, let's do our multiple equations to practice using our kinematics. All right, so for this guy, I'm going to plug in my numbers from the right side of my table. I'm going to rearrange this guy to get that. From there, I'm going to solve for t, right? So I'm going to move a t over. Watch me algebra. Divide both sides by 4.9. My t is going to come out to be a little bit more than 4. .68. Remember that when we do this problem, sometimes we're doing multiple of them. So you want to go back in and you want to make sure you're filling your table as you go. It will also remind you that the final answer to any of your problems is worth 1 of the 7 possible points, right? So make sure you're answering the questions and you're showing the steps because we've harped on them this whole semester on purpose. Okay. Now we're going to take that number for t, plug it in for the x formula, and see what we get. I get 90.42 meters. Okay, let's do it the other way. Let's do the shortcut. Say again?
I thought we were doing all of that to get to the shortcut.
Nope. The shortcut formula says that you can plug in the initial speed without breaking it into components, multiply by the angle, the sine of 2 of the angle, and then divide by the gravitational constant. And that'll get us the range. Remember that range is a shortcut for x minus x naught. Please make sure that your calculator is in degree mode. My number came out slightly different. Why did my number come out slightly different? Rounding. 100%. Yep.
Did you say that we can only use the shortcut when the y and the y naught are both 0?
So when it starts on the ground, ends on the ground, that's when the range formula applies. And the range formula is not on your formula sheet.
So do we have to memorize that?
If you want to use it, you have to memorize it, and you better memorize when you're allowed to use it. I would recommend not even bothering. To be honest with you. I would recommend not bothering to remember the range or the height formula, because the height formula has similar requirements.
Okay.
You know how to use kinematic formulas. We got the same answer twice, right? So you might as well just use the kinematics that you're given and make sure you can go through and do the steps that we've talked about. Okay? All right, what else do we want to work on? We have 10 more minutes.
I have a question.
Yeah.
Can I bring moral support to the cookies to class?
Can you bring moral support cookies? Yeah, sure.
That's actually such a good idea.
Tomorrow or the final?
Tomorrow because I feel like it might distract us from the
Okay.
final.
Okay, so has anybody not been able to find the formula sheet, have questions on where that's located? Good, we've seen it. Your study guide should have already been turned in. If you haven't, please make sure you remember. This guy is due by the day of the final. So if you're turning in a tissue box, get it turned in by the day of the final. If you still haven't picked somebody and you decide on Tuesday night that you want to do this, you better be emailing me and you better hope that I'm checking my email at 9:30 at night to make sure, because you are not just supposed to pick someone random, you are supposed to get it approved. I don't want 20 tissue boxes about Isaac Newton. Thank you. Yes.
Can we do a practice problem from chapter 3, like another one?
Sure. You want to do another projectile motion? Let's do one with something on a ramp. Or do you want to do an additional velocity?
I don't know if that's what I'm talking about. I'm talking about like doing one with like the directions.
Okay. Yeah, let's do that. We feel good about kinematics, hopefully. Feel like you can do this in your sleep yet?
Can I go to the bathroom?
Yes, you may. Let's find another river problem. I don't like them, but they work. Ooh, maybe an airplane. Let's find an airplane with some air. Some wind resistance.
What about the thing where it was like, I hate it.
There was a galaxy problem where you had to like readjust everything from one new point. You remember that one?
It was like our air in respect to like bird, wind in respect to wind.
Are you talking about the owl?
I don't know.
The owl and the mouse and the nest? No?
Well, it was just like they were just weird ones where you had to have all these resultants, and then it was like all in respect to something else. So it's like a bird is traveling.
A seagull flies at a velocity of 9 meters per second straight into the wind.
And then it goes back home, and then it's like a whole thing. Yeah.
Yeah.
That's what I'm talking about.
Yeah, let's do that one. A seagull.
Are you putting those on the test?
What?
I hope not.
I hope not too.
What?
Are you putting these ones on the test?
I won't, the seagull will not be on the test.
Thank you.
Okay. Flies at a velocity of 9 meters per second. Remember that in this chapter we talked about the term relative to something. This one is straight into the wind. Okay. A, if it takes the bird, "20 minutes to travel 6 kilometers, what is the velocity of the wind?" Okay, here we go. That's my bird. You're welcome. He flies straight into the wind with a velocity of 9 meters per second. That means, which direction does the wind point? Straight backwards. Towards the bird, right? You guys are doing really great. Okay, so this is the situation. This is not my vector diagram. Okay? This is the wind, this is the bird. We don't know the velocity of the wind. We are, however, told enough information to get the resultant velocity. Technically, we don't actually know. My assumption is that VR is going to point to the right. Why? Because he's aiming that direction, right? And it does say he eventually arrives somewhere. So since he's trying to go that way, the resultant is going to end up to the right. Okay, so now let's actually draw them all together. If we're adding the velocities, we do head to tail method. So this one is V bird, this one is V wind, and then change my marker color. That's the resultant. Okay, so let's use our information to get our V resultant. A velocity is just a change in displacement over time. His displacement is 6 kilometers, which is 6,000 meters. 20 minutes in seconds is what? We want to get it into seconds. 20 times 60. So 6,000 over 1,200 is what? Decimal, please.
Why do I try it?
What is it, 5?
Why do I rely on my brain?
No, I stood at that and was like, yeah.
I was like,
For a
wait, this
minute
one
too,
I was
so-
like, wait. No. I thought there was an extra zero. That's why.
Okay, so V resultant is 5 meters per second. We want to know V wind. So V bird plus V wind is going to equal VR. These are all in one line, right? There's no angle. So
Normal number. So X is negative 4. Wait. Wow. Is this the final? Is this the final?
wouldn't that be nice? Setting up algebraic expressions and solving for the
I
values.
know.
I love you all, but I think the problem here is the drawing of the picture. If you draw the picture,
Really? I thought it was the algebra. No,
oh, seniors. All right. Yes.
Is there going to be anything at the final where, like, you get an angle, like, on a axis, I guess, or
Yes.
a graph?
An angle?
You get an angle and you have to calculate the other angle so you get like the right answer. You know what I'm talking about?
Yep.
It's definitely a deception.
Oh.
You know? You know, there's
I know what you're talking about.
Say again?
Like the problems that we were doing on the graphing paper.
like sometimes the angle that they give you is not the one that you should use in your problem. You have to calculate.
Oh, you're about, okay, I understand what you're saying. You're saying like, okay, if a bird flies at 30 degrees south of west, is that what you're asking?
Yeah.
So yeah, you're talking about converting angles. I don't remember off the top of my head if there's one on there, but let's do it just for, let's do it for fun. Where is west?
Wait, what is that?
Never eat sardines.
Okay, where's south? Okay, south of west. You always identify the of first. So the of is west, right? And then we're going to go south of it. And we're going to go 30 degrees south. Okay, so now I want to convert that angle to the 360 degrees, right? How do we do that? So you would do 180 plus whatever the angle is in this case. So this would then become 210 degrees.
Why wouldn't you go back that way?
This way? This would be a negative angle, right? And it would be,
It'd be negative 150.
would you get the same answers either way?
Yeah.
If you plug these into the sine, cosine, tangent, you should. If we're down here, despite all of it, if you can identify what quadrant it's in, can you tell me the sign of Vx and Vy? In the third quadrant, they should both be, if you can identify the quadrant, just make sure that the component is the right sign.
Why do we do that again? Why can't you just use the 30 degrees?
Because if you use 30 degrees, you're telling it you're here.
Oh.
And that makes your x and y components positive when they're supposed to be negative. That's why.
For all problems that happen like at any
If
angle,
you're not,
if it says a direction, you have to convert it.
I would say if it gives you like south of west, east of south, or whatever, yes, I would convert.
Okay.
You want them all converted back to 0 on the unit circle.
Right.
Might be, should it be 240? So the
It's 180 plus the 30.
Oh yeah, 180.
Yeah, because 180
Okay, yeah.
degrees.
And then you, so.
Oh, 270. Isn't that 270?
The bottom one
Oh.
is 270.
Oh.
270, 360, 180, 90.
Okay.
Welcome back, Mel. Welcome back just in time for final exams. Get excited. Okay. We're just gonna continue. We're gonna go over chapter 4, and I'll have a video posted. So that's what I do for my remote learners.
Okay.
Bye, guys.